We will start this question bank right now. In this question bank, integration of 1 by x sine square into log x dx. Okay, so this is the question what we have got. So this question 1 divided by x sine square log x dx, equation 1. Okay, this will be, we will be putting equation 1 because we need this equation later on. So here we will be putting log x as substituting, so as z. So firstly we need to take, you already are aware regarding the substitution. So in this substitution what we do, we differentiate with respect to x. Okay, so this function became dz by dx equal to 1 divided by x log of, if you take differentiation of log x, it is 1 divided by x. So this dx, if you take on the opposite side, dx by x. Okay, so dx by x, you can see this, there is dx also in the equation 1 and x also. So substituting this, okay, you will get sine square, this would be z, we have taken z, and since dx divided by z is dz, we have put dz. So this equation got converted into this form. Dz we have found from here, dx by dz. If you bring this x over here, you will come to know this is whole term is z, so that is why this numerator has become dz. And this sine square, this was taken as z. Okay, so this the sine square z is there. So integration of 1 divided by sine square is cosec square z. So this dz is already there along with that. So dz we have brought over here. So integration of cosec square z is minus cot z. Okay, plus c. So plus c we put after integration. Integration of cosec z into dz is minus cot z plus c. So putting the value of z again. Okay, so minus cot, instead of z we will be putting log x plus c. Okay, this is the final equation. Question, we have this question, integration of root x sec x raised to 3 by 2 into tan x raised to 3 by 2 into dx. Let me consider this question as equation 1. Okay, so we will be substituting this x raised to 3 by 2 as z. Okay, once we take this as z, differentiating with respect to x, we get dz by dx. Okay, this would be integration, you know already, dx, d by dx of x raised to 3 by 2 is, this n will come forward, this is whole n term, 3 divided by 2 raised to n minus 1, x raised to n minus 1. So n is 3 by 2, 3 divided by 2 minus 1, dz by dx 3 divided by 2, and this, if you take LCM, this 2 will go over there. So 3 minus 1 is 3 into 2, this 2 into 1 is 2, and 3 minus 2 is 1. So that is how we got this half, x raised to half. Then this 2 by 3, this 3 by 2 we can take on the opposite side. Okay, when we take on the opposite side, you will get this dz by dx is already there. This 2 will go on top and 3 will come in the denominator. So this we can term as root, okay, square root. So under root of x. So 2 divided by 3 dz by dx equal to under root of x. So to this, if you compare with the main equation, you can see dx is there. So dx, if you take on the opposite side over here, so you will be getting this first term and this last term. So you can see this first term and last term can be replaced by 2 divided by 3 into dz. So this value you can substitute in equation 1. Okay, so integration, you will put this integration over here. Integration, this will become sec, and this x raised to 3 by 2 will become z, tan this x raised to 3 by 2 will become z again, tan z. Okay, and this square root of x under root of x into dx is equal to 2 divided by 3 into dz. This we have got from this equation. Okay, 2 dz divided by 3. So if you take the integration according to this formula, you can see integration of sec theta tan theta dx is equal to sec theta plus c. Okay, so sec theta into tan theta dx is equal to sec theta plus c. Okay, so this, if you compare, instead of theta here z is there, so this equation will turn into this form. Sec, instead of theta it would be z, and this 2 divided by 3 will also come. Okay, this 2 divided by 3, 2 divided by 3 into sec z plus c. So z, we can't write the formula, the final equation in the form of z. We will be resubstituting the value. So 2 divided by 3 into sec, okay, x raised to 3 by 2. Instead of z, you will be putting x raised to 3 by 2 plus c. This is a new question. So this question is integration of e raised to 2x plus e raised to minus 2x divided by e raised to x into dx. Okay, this is integration of. So this, if you can see, integration we can put it outside in square bracket. E raised to 2x can be written as e raised to 2x divided by, this can be split into 2, denominator e raised to x plus, there is a middle sign, plus is there. Okay, and e raised to minus 2x is there over here, divided by, this is split into the second term. Okay, e raised to x. So according to this indices formula, a raised to m divided by a raised to n is equal to a raised to m minus n. So this, if you can see, if this e raised to x is taken on top, according to this indices formula, it will become minus. Okay, e raised to this minus 2x is already there. This, if you take on top, it will. So e raised to minus 2x minus x plus e raised to minus 2x minus x, square bracket close, into dx. Integration of this will become e raised to x, because x will be left over here after you minus these things, and this will become addition. Minus and minus will become plus, but it will leave a sign of minus itself. So this will be minus 3x, e raised to minus 3x, bracket close, square bracket close, into dx. Integration of e raised to x, this dx will get multiplied with the first term, plus this integration will come to the second term also. Integration of e raised to minus 3x, this dx will get multiplied with the second term as well. Okay, so integration of e raised to dx, e raised to x dx is e raised to x itself, plus e raised to minus 3x into this. Since this is a composite function, the derivative will be inverse. So 1 divided by derivative of this term, minus 3x. So minus 3x dy dx of minus 3x, in the denominator you will get minus 3. Okay, and the whole term would be e raised to x plus e raised to minus 3x, 1 divided by this minus 3 we have got after taking derivative of this. Okay, plus c, and the final answer would be e raised to x minus, this minus sign will go over here, this denominator minus sign will go to here. Okay, here it will be minus e raised to minus 3x, this 3 will be going over here in the denominator, plus c. This is a separate question. Integration of x raised to x, bracket open, 1 plus log x, bracket close, dx. So we will solve this integration by substitution. So let us take this x raised to x as z. So using log on both the sides, we can solve this. We have to take log on both the sides. Here also log we have taken, log z equal to this log x raised to x. So this can be, according to indices rule, anything raised to will be coming on this side, okay, down. So here log z is equal to x log x. So now differentiating this with respect to x, you will get differentiating this value first. Okay, this value if you differentiate, you will be getting 1 divided by z. Okay, since this is a composite function, we have to differentiate this twice. Dz by dx equal to, this is u into v form. So this is u, this is v. So this would be u into derivative of v plus v into derivative of u. So here x is there instead of u, derivative here v instead of v, log x is there. So derivative of log x plus log x into derivative of this u. Instead of u, it would be x. So here 1 divided by z into dz by dx is equal to, here derivative of log x, you will get x into 1 divided by x. This both terms will get cancelled, plus log x in derivative of this term into 1. Dz by dz divided by dx is equal to, now this z will go on the opposite side. Here you will get this z will come on here, and here this term will get cancelled. These two terms will get cancelled, x and x, since these are common terms. You will get balance 1. Okay, you have to put the bracket open, 1 plus this log x. So anything into 1, you will get that value itself, log x, bracket close. So this if you take on the opposite side, you will get dz equal to z, bracket open, 1 plus log x into dx. Okay, so this, if you see this term, you can see, and you can compare this with this term. Okay, so you can compare this with this term. So now instead of putting z, we will be putting dz x raised to instead of z, we are putting this term. Okay, z is equal to x raised to x. So x raised to x, 1 plus log x, bracket close, dx. Okay, so this term, if you compare with this term, you can see instead of this whole term, you have to just put the value dz. So that we will be putting. So this I have put from the question itself. You can see from the question itself. Okay, so if you see this, if we put this as equation number 1, so from equation number 1, this will get converted. This whole value we have seen over here, whole value is dz. Okay, so dz will come over here. Integration of dz, as you are already aware, is z itself. Okay, plus the constant c. So we can't put the value of z as a final answer. So we will be resubstituting the value of z. It is x raised to x. So x raised to x plus c. That is the final answer. We will be solving this problem right now. So this is a separate question, as you can see. Okay, so this is a separate question. This question states that you can see integration of e raised to x, bracket open, x plus 3 divided by x plus 4 the whole square. The square is there over here. The bracket close, dx. So integration of e raised to x, you can see this can be solved using this. Okay, we have just put plus and minus 1, plus 1 and minus 1, okay, on the numerator. So what the benefit of this is that once you put this, it can be split into two parts. Okay, so we will see that how it is split into two parts. Here you can see x plus 3. Okay, this we have taken from the top itself, the numerator you can see, plus 1 we have put initially, and then minus 1, and denominator we have taken the question, in the question itself you can see x plus 4 the whole square, bracket close, dx. So integration of e raised to x plus this would become 4. Okay, so 3 plus 1 is 4, and this minus 1. So this this we have taken as a separate function itself. Okay, you can split into two parts now. So this numerator and this denominator, okay, over here will be common. Minus sign is there in between. 1 divided by this denominator, you can see you have to put the square of that, x plus 4 the whole square. Okay, so the benefit of putting plus and minus is that you can split this into two parts. Why we have done that is, you can see right now itself, you can see the denominator and the numerator is one and the same. You can see you can cancel this numerator and denominator. That is the reason why we have split into two parts, and you can see we have taken this only in the first part. So this will get cancelled, fully cancelled, you will get remainder 1, and this square will get cancelled and you will get 1, x plus 4 only. Okay, so this square will get removed. Okay, and you will get x plus 4 only, and minus 1 divided by x plus 4 the whole square. Here the term will be unchanged. Okay, you have to put the square bracket over here dx. Now you can see over here, according to this formula, you can see this is the formula you need to by heart. This is a very important question that has been asked in the board exam. This formula, you can see e raised to x is there in the formula itself, and you can see in the question, in the solution also you can see e raised to x. This, if it is f of x, then the next term should be f dash of x. F dash, in a sense, it should be the first derivative, dy by dx. So we have to take d by dx of this first term. If you take d by dx of this first term, okay, derivative of this first term, you are already aware, we have already done that d by dx of 1 by x is equal to minus 1 x square. Okay, so derivative of this term, the first term, you will get minus, okay, according to this formula, minus x square. Instead of x, you will be putting this, okay, x plus 4 the whole square. Okay, so you can see if this is f of x, then this has to be f dash of x. So according to this formula, you will get the answer is same, e raised to x. Okay, f of x, this function x, you will get plus c. So this formula has reduced this sum into only one step, you can see. So instead of doing several steps, so this is an important corollary, e raised to x, f of x plus f dash of x dx is equal to e raised to x, f of x plus c. Okay, this working you have to show in the examination. Now we will be proceeding further. So you can see this has got converted, and you can put f of x directly. So this problem can be solved like this: integration of e raised to x, f of x plus f dash of x bracket close dx can be written as e raised to x, f of x. This is our f of x. So this function will come as it is, 1 divided by x plus 4 plus the constant c. Okay, so this big equation has got reduced to one line, and we have got this final answer. So we will be arranging the terms right now. This e raised to x into 1 is e raised to x itself, denominator x plus 4, and this c. Okay, this is the final answer. Now we will be going to a separate question itself. So this question you can see out here. The question is integration of log x divided by x into dx. So let us take this question itself as equation number 1. So we will be solving this equation how? By substitution. So solution is, we will be putting z as log x. So now z as log x, if you put the numerator as log x, we have to integrate this. Okay, so differentiating with respect to x, we get dz by dx. Okay, dz by dx, and this integration, if you do, d by dx of log x is 1 divided by x. This, if you take on the opposite side, okay, of the equal to, you will get dz is equal to dx by divided by x. This you put in equation number 1. This is already x z itself, and dx divided by x. Okay, dx divided by x over here is dz. So this is how the equation 1 got converted into integration of z dz. Okay, so these two values you have to put in equation number 1, and it will get converted over here. And integration of z dz. Okay, z, you are already aware, it is integration of whatever the function z raised to n over here is 1, so 1 plus 1, n plus 1 divided by n plus 1. So here n is z raised to 1, so z square divided by 2 plus c. You can see over here, z is, we can't put the answer as z, so final answer you have to resubstitute and put the value of z. Instead of z you will be putting log x. Okay, and the square is there already. Okay, z square, so that is why you have to put, instead of z you will be putting log x, then the square divided by 2 plus c. This is the final answer. This question is like this. Question, integration of bracket open 2 plus cot x minus cosec square x bracket close e raised to x dx. So this equation can be easily solved using this formula. We had seen this formula earlier. This is e raised to x, integration of e raised to x bracket open f of x plus f dash of x bracket close dx can be easily integrated, and this is the final answer, e raised to x into f of x plus c. Okay, so we have to find out what is f of x. So if we take this, the first term, as f of x, 2 plus cot x, we have to take the derivative first and see whether it is f of x. So derivative of 2 plus cot x. So 2, if you take derivative of 2, the answer is 0. And if you take derivative of cot x, you will get minus cosec square x. Okay, so you can see you have got the second term. Second term is d by dx. Okay, so this is f dash of x. So you have successfully solved this formula. How? By e raised to x is already there. This is f of x and this is f dash of x. So this is in minus, but you have to take this minus sign with the minus sign. Okay, so you can solve this line using this formula. So this equation, integration of this function into dx, you will get the answer, final answer, e raised to x. This is f of x, that is what written in the formula. Due to this corollary, you have solved these steps in two steps itself. Okay, so f of x is over here, you have to put f of x, it is 2 plus cot x bracket close plus the constant c. So this is the final answer, e raised to x into 2 plus cot x bracket close plus the constant c.